Alright folks, welcome to webinar number 8, Critical Standards for Maintenance Providers, and I'll have to do some explaining about that. If I understand it right, everybody who has been here before. Anybody who hasn't? So if that's the case, we can skip all this stuff once again. Just remember *6 to mute your phone, *6 to unmute if you want to ask a question or join a discussion. Interject anytime. We're recording it, but we're not recording you, just me. Don't need my bio. We don't need any of this stuff then. So the intended duration an hour, and some of you may decide to sign out sooner than that. I'll explain why in a sec. We mentioned the learning resources again, which will have recordings of the webinars that any of you have missed. Do I need to go there again? Probably not. Everybody can Google OWRP or SPM learning resources and get to the recordings of previous webinars. CPD was a quarter point per webinar, 1 for 4 webinars. Any questions or discussions on any of that so far? Okay. Learning goals, once again, to focus our thoughts. Going to look at MP's responsibilities for SPM compliance beyond just the maintenance standards, and summarize some of the key changes to critical standards, learn how to find stuff and apply things that are applicable to maintenance providers. Installer, that should have said maintenance providers. So maintenance providers should access these, especially if you need to write an exam. And if you didn't catch these the first time, to prep for the exam or just to learn stuff, webinar number 1 dealt with how to find things, went through some of the key changes in the SPM. Webinar number 5 was for specs and install standards, which we think maintenance providers need because maintenance providers do repairs often. And then here's the kicker, I suppose, is webinar 7 was for maintenance and monitoring standards. This one is not. This one is about things that are not in section 7 of the guidelines or the standards. We did that the other day. So this is intended to be similar to the one we did for installers, where we went through vertical separation, horizontal setbacks, DDF, and so on. The first portion of it will set the stage, and it'll probably be helpful to you even if you attended these previous ones. But partway through, I'll let you know when we get back into DDF, VS, and setbacks. And then at that time, if you took those previously, then you may decide that you want to log out. A bit repetitive, but slightly different focus. Quotes are in italics. Let's get started. So, goals for maintenance providers, basically the same goals I threw up there last time. Hopefully this is what we want to do. Stay out of trouble and be good at it. Maintenance providers then have to fully understand SPM maintenance and monitoring standards and guidelines. Hopefully that's obvious. You need to be able to understand maintenance plans, create maintenance plans, identify problems, and actually do the work properly, including making conclusions about the capacity and performance of the system. And that's kind of new in this SPM. So if we're going to make conclusions about whether the system is big enough to support the use, then we need to understand how to determine daily design flow and some other things. If we're going to comment about the performance, then we need to understand some of the other standards, the fundamentals at least of some of the other standards, like VS, horizontal separation, and DDF. And if you attended the previous one, for install, same thing applies to MPs, is we share responsibility and liability risks with the other APs. You know, if we do a maintenance service call and we don't point out to the owner that their system is less than the required setback to a lake or a creek or a well, then we would be in trouble if we didn't point that out. So the concept of shared liability, as an authorized person, we're responsible for SSR compliance. As a ROPE, we're responsible for code of ethics and other associated on-site wastewater certification board policy, practice guidelines, and so on. And as a contractor, you got lots of liability. Lawyers sue everybody. Judges will evaluate everybody, including the maintenance provider. They'll evaluate your due diligence. At law, you're a professional, which gives you a burden of due diligence that a layperson does not have. You need to be prepared to demonstrate due diligence. And maintenance providers are exposed to risk related to system performance in a fairly significant way. We can make a lot of errors. We can do a maintenance service and then say the system is just fine, shouldn't have any problems. And then if somebody else finds out that the thing is actually posing a health hazard, for example, we're in trouble. We do now make conclusions about system performance and suitable capacity of the system. So for that reason, maintenance providers need to know what standard practice is, and the best defense is due diligence. A little more on that later, but due diligence is just a legal concept that sort of goes like this: is what would a reasonable person do or conclude or recommend? And in order to prove due diligence, we need to do some things, including taking pictures and so on. We have to do a written report for maintenance, and volume 3, 7.23. Just going to hit on a few key points because we went through this the other day. 7.2.3. There it is. Make this bigger. Okay, so we have to now, this is under the topic of the written report of maintenance, not a maintenance plan, but rather the maintenance report that we give to the client, the owner of the report. And one of the things it says we have to do now is if the system's being used in a manner consistent with its design capacity. So now we need to know what the design capacity is, and an evaluation of the system's performance, including making conclusions about repairs and recommendations for improvement and so on. What else did I have in here? See what I had in my slide. There we go. Summarizing it, making conclusions, list of recommended repairs or improvements, reason why it should be done, indicate any repairs that will require filing under the SSR. So that's one of the topics we'll revisit tonight, is when a filing is or is not required. A short version, if we're recommending that they need a new septic tank, then we need a filing. If we're recommending that they should put in an effluent filter, we don't need a filing. Terminology, 7.2.3.1. 7.2.3.1 in the guidelines says that within our reports of maintenance to the clients, we need to use the ASTTBC terminology for inspection. So we need to use that same terminology. Let's have a look at it. So back to here, and that would be in Appendix G in our policy, standard guidelines for inspection, that everybody should be familiar with and have. So the language we are talking about is this going to get any bigger? Zoom. Well, that's probably big enough. So all of this policy will be important for inspectors, but for reporting, the terminology we're talking about is this familiar stuff. So it lists, I think, from A to J or something like that, quite a few different bits of terminology. And we spent a bunch of money on lawyers on that. This one, for example, is not saying everything's fine, you shouldn't have any problem. It's saying it's operating in a normal manner as intended by its design, which is going to keep you out of trouble. That's a lot better than saying everything's just fine. And here's some more. The system's operating, but a partial restriction or backing up doesn't mean that it needs replacement. It means that there's just that, partial restriction or backing up. Performance malfunction, backing up is found, wastewater is escaping, those kind of things. No visible flow in some of the laterals in a gravity system. All means a performance malfunction, which is a lot better than saying the system has failed or the system needs replacement. Trying to keep ourselves out of trouble. This one, D, is for when we can't find everything, which is often the case. You know, we can't get access to the tanks because somebody poured a concrete deck over it, or a number of other things. It could be that landscaping has hidden the D box, or a bunch of other things. And that's important. Important to say what we didn't find and why. Illegal or prohibited feature. This is the right time to point out that these different bits of terminology can be stacked together. It could be that the system is operating in a normal manner, but it could also be that there's an illegal or prohibited feature. So you can stack them together. It could be a diversion that allows effluent to escape, or a pipe heading to the creek or something like that. Could be that a second residence is connected which exceeds the DDF, the original design. That then becomes a prohibited feature. It doesn't actually mean that they necessarily have to do anything about it. If there's a health risk, that's a different story. So I suppose my example of the pipe leading to the creek would be that. In that case, we'd have to report the health risk. But if they have hooked up a second residence and that then exceeds the original design flow, all we're doing is reporting it, unless there's a risk of health hazard. Here's some more potential health or safety hazard. That could be that somebody's got a plug inside the pump chamber, for example. I would argue even the NEMA 4 junction box inside the pump chamber is a health hazard because it's not waterproof. So then there's electrocution hazard. It mentions electrical hazards. And then we get improvement, caution, and so on. So that's the terminology we were talking about that now needs to appear in our reports of maintenance. And that's a huge change. It's a big change in the SPM. There it is. My slide just repeats it. We got to use that terminology. Photographic evidence. It says that we do have to take photographs to document maintenance. Got to keep them as a long-term record, and then we may consider adding some photographs in the report to the owner, especially if we're reporting a malfunction or a required improvement or a health hazard for that matter. Then we need photographs to sort of back up that conclusion. So just like for planners and installers, photographs are no longer an option, and our policy basically says the same thing. Thou must take pictures. It also gives us guidance on how those pictures should be taken, before the site's disturbed, any exposed components, adequate detail to document anything needing repair or performance malfunction, illegal features, and so on. We need photographs to back up that conclusion. And then after, and I've mentioned this a number of times, mostly it's to cover our butt. Some kid falls in a septic tank lid the day after we leave, we better have a picture showing that we had secured the lid, and so on. So photographs are important, and that's easy these days. It's one of the best bits of advice to stay out of trouble is to have photographs. And there I'm just repeating that content. Liability, minimum scope of maintenance. So the SPM says that at each maintenance service, in addition to whatever is in the maintenance plan, we have to do a bunch of things. There it is there. In the guideline, at each maintenance service, in addition to the maintenance plan. And then it lists pages and pages of things that maintenance is supposed to be. Maintenance tasks and so on. So, 2 points there. One is that we have to follow the maintenance plan. The second is that if the maintenance plan doesn't capture some of the things that should be done, then we got to do it. It could have left this out. It could have left out assessing the condition of media. It could have been all kinds of things. It mentions there if backups are observed, use a pipe camera to check. Mentions excavating by hand if there are signs of backup, drainage ditches, and so on. I'll move on. The point of this is that we need to do what's in the maintenance plan plus the following, and the following is basically the full scope of maintenance that's described in great detail within those sections. And that stuff we did the other night, everything that maintenance is supposed to be. Repair work by maintenance providers. We've kind of been here before, back in webinar 1, I think it was, but we want to be sure to go there again. Minor repairs and replacement of some stuff can be done within the scope of maintenance. Major repairs fall outside the scope of maintenance. So major repairs require a filing, and that means they can only be carried out by authorized persons that have been registered, qualified, and accredited to plan or install systems. 2.1.2. Let's see now. 2.1, that was wrong. 2.1.2. I always make that mistake. So it's this table that we've looked at before. So component repair, maintenance provider can do without a filing. System repair, a maintenance provider cannot do unless the maintenance provider is also an installer, and those do require a filing. So now you also need a planner or a professional. To put it a different way, if you're a maintenance provider, installer, and planner, you can do all those things. If you're just a maintenance provider, then you can do those things and that's it. Clear as mud. Any questions or discussion on that topic? Because that's fairly important, and that'll catch people off guard or by surprise if they've missed some of the previous webinars. Okay, no questions. So therefore, to wrap up the sermon, comply. The standards and guidelines for maintenance were in webinar number 7. And then the fundamentals of critical standards, that's what this webinar is about. Horizontal setbacks, vertical separation, and so on. Maintenance providers have the primary responsibility for Section 7. Section 7 in the standards and Section 7 in the guidelines. And they have a shared responsibility for Section 5 and other sections, just as a standard of due diligence, code of ethics, and so on. So SSR compliance includes things like needing to be an authorized person and submitting filings before doing system repair and certifications and so on. Where are we going? Comply with code of ethics and policies, demonstrate due diligence. A little more on that later. No, a little more right now. So due diligence is all about being able to prove it, which means we need records and documentation, photographs, good business practices. That's part of demonstrating due diligence. I hope that's clear. And just basically following the rules. And if we're not doing those things, then we're in trouble due to a lack of due diligence. Some of the competency gaps I see: business practices, lack of contracts. Most people who are in trouble with a complaint from the public wish they had a contract. And for maintenance, I think it could be quite a simple contract. You know, maybe even a one-page form, although I'm not a lawyer. You know, you need to consult a lawyer if you're going to come up with your own contract. Insurance is a big deal for all kinds of reasons. What do I need to say about that? We need liability insurance, and you might want to consider errors and omissions insurance, because now you're making conclusions about the capacity and performance of the system. Got to watch out for conflict of interest. If you're well, let's think about one for maintenance. If you had maintenance contracts to service a particular type of treatment plant, you have to be careful not to recommend to every single client that they get that type of treatment plant, Maybe I didn't put that well, but watch out for conflict of interest. SPM knowledge and compliance, especially new registrants. Been down this road before. I think we have 200 or so registrants who came through Alberta, which is great, except that they need to understand that the Alberta training was for the Alberta standards and regulatory framework, which means you're going to do an awful lot of self-study of the SPM to get up to speed. Lots, like 100 hours, maybe more. Limited mentoring is a problem. We talked about that. Maintenance providers, there's not very many, so I think it makes it even more difficult because you need to work underneath the oversight of an authorized maintenance provider or a professional in order to get your certification. And that's that catch-22 thing, is nobody wants to train up their competition. But there are ways, and there are people who are willing to do that. After we had this conversation in the last webinar, I got at least one email from a person in the Lower Mainland who said he would be willing to mentor people. And I think the implication was for fees, but that's the way it goes. So documentation, job records, logbook, proper files with backup systems. You need to be able to find the records for any job anytime. Contracts, including emails confirming agreements, and in this case, I think for maintenance, including permission to enter the property. And something that says in legalese, in better language than what I'm about to say, something that says I might break things. And that may not be my problem. Maintenance is a bit dodgy because oftentimes we're digging up D boxes that are 20 or 30 years old, for example. So the minute you dig up the D box, it all crumbles apart. And then you have to say to the person, you need a new D box. Well, now that brings up the argument about whether it was your fault or not. So having something that says that there could be some damage is important. Photographic record, once again. Maintenance service reports are often very poorly done or not at all. Sometimes people don't issue a report whatsoever, and clearly we have to. Competency gaps, beaten up on maintenance providers. Disregard for the maintenance plan. I hope I'm making that point clear, is maintenance providers have to follow the maintenance plan that a planner or an engineer created, and they have to do those other things that we looked at a few minutes ago. Have to have the maintenance plan and have to follow it. And that puts the burden on our planners to make sure they know how to do a good maintenance plan, but that's another story. Inadequate scope of maintenance, including just the septic tank or the treatment plant. And I realize it's repetitive if you've been here before, but if that's what you're doing, don't call it maintenance. Call it septic tank pump out or treatment plant service or something like that. Maintenance includes much more than septic tank or treatment plant maintenance. It includes inspection and service of the soil dispersal system, for one thing, and dealing with flows and making conclusions about capacity of the system compared to use and so on. I guess I hit on that already. Bad maintenance service reports, vague or flawed reporting terminology, which goes back to that problem where they say, the system has failed, or the system needs replacement, or the system is just fine. Don't worry about it. It's going to work great. All of that is going to get you in trouble, and that brings us to that reporting terminology that we looked at in Appendix G of OWRP policy. Poorly equipped MPs, maintenance providers need a pipe camera and some other things. Code of ethics, business practices, self-assessment of competency, scope of work, doing CPD. That's the short path to trouble if you're not familiar and complying with the code of ethics. And then the policy, including things like oversight of non-authorized persons. The short version is that if you have staff or helpers or whatever who aren't ropes, you have to provide adequate oversight, which means basically you have to be there more or less 100% of the time. And that's all laid out in policy. Adequate scope of maintenance and equipment is listed in the policy, the reporting terminology that we looked at, and adherence to the SPM. As I think everybody knows, Our policy says that ropes have to follow the SPM, period. Period and not period. It means that if you're a professional, you don't. You can do custom design, you can do your own math to determine how things should be designed. But for ropes, we have to follow the SPM with a few exceptions. I mean, we can depart from critical standards based on written advice from a professional. We can depart from guidelines based on our own written rationale. At any rate, that's still basically following the SPM, because Volume 3 is guidelines after all. So Code of Ethics, download and print those, comply with those, and prove it. SSR compliance. Maintenance has to be performed by authorized persons. The SSR says construction and maintenance must be this and that and the other thing. One of those being it has to be done by authorized persons. What else do we want to say about that? Well, I guess just that. Maintenance is not just installation and design, it's also maintenance. So owners who are getting maintenance done by a non-authorized person, or even doing it themselves, frankly, are in breach of the regulation. It's an offense. And then maintenance has to be performed as per the maintenance plan, because the maintenance plan is mentioned in the SSR. It's a key requirement that owners have to follow the maintenance plan as filed. Again, if they don't, they're in non-compliance. So we're trying to educate our clients that the maintenance plan is something they're actually obliged to do. And system repair requires a filing and certification, because system repair is construction, not component repair, but system repair. Back to that table that had the two columns. So that requires a filing before the work is done, certification within 30 days, and so on. And then system repair has to be done by an authorized person. It doesn't actually say with installer certification, it says with appropriate qualifications or something like that. And then there's another whole section in the regulation that says that appropriate certification is ASTT registration, according to our policy, which says that if you're doing system repair, you have to be an installer. You can't be a lowly planner. You have to actually be an installer in order to do system repair. Any questions or thoughts on that? I'd invite that, because that was actually quite a bit there. Anybody want to chat about that? Okay. Maintenance and monitoring standards, a whole bunch of changes in the SPM, including frequency and procedures and having to make conclusions about performance and capacity and other things. And a maintenance provider needs to fully understand those, need to be experts at those. And those were the topic of webinar number 7. And even if you attended that, you're still going to need some self-study to go through that. Applied best practices, critical standards. Okay, I guess I'm repeating myself. Obviously, MPs are responsible for Section 7, Maintenance and Monitoring Standards and Guidelines, topic of a previous webinar. But also, MPs need to ensure the system meets the fundamentals of Section 4 and 5 critical standards. And that's where we get into DDF and horizontal setbacks, vertical separation, whether gravity is allowed or not. So either, the reason I put in the next point is or, is because, need to ensure, or retain on file written proof that you informed the owner about the non-compliance. And maybe I should have had another or. The other or is if it's a health hazard, then you have to retain written proof that you reported it to the health authority. But what? But if it's, DDF calls for a system that has 200 feet of trenches and they only have 100 feet of trenches, you don't necessarily need to actually fix that, but you need to recommend to them that they do, that it's apparent non-compliance. Hopefully that's clear. So to stay out of trouble, all this stuff. Study and comply, actually know what all these things require, and do continuing professional development. It's a requirement. And particularly for MPs, it's the same stuff I brought up the other night. Get a camera, get a pipe camera, and get locating equipment. I guess I could confess that I sometimes do maintenance on my own systems without a pipe camera, ones that I put in recently, because I know where everything is and it has access provisions. But certainly if you're going to do maintenance of systems that are not yours, you're going to need a pipe camera to locate things, especially if you're maintaining systems before the regulation. Pipe camera not only to locate but to inspect and so on. And then locating equipment. Well, I don't have any, but there's been times where I've got somebody out who does, you know. So this is my truck driver language. When I say get, I mean it doesn't necessarily mean that you have to have $20,000 of locating equipment, but you need to be prepared to get that when you need it. And then don't work cheap. Talked about that in other contexts. So for maintenance, you got to charge enough money that you can do that incredibly long list of things that we have to do, especially the initial service where we had to have somebody in the house. We had to find interceptor drains, and we're probably there for 4 to 5 hours or more. And should we go down this path? How much? Why not? Anybody want to talk about how much maintenance costs? I'll start. If you're reluctant, it's not $100, you know. I don't know. I would suggest it's just my own personal practice is that you're looking at $250 for a very simple maintenance of where you know where everything is, and then it just goes up and up from there. And then it shouldn't necessarily be a fixed price period. It should be a fixed price with exclusions, so that if you bid on maintenance and you say it's going to cost $350, but then you get there and you realize that the septic tanks are 6 feet deep or something like that, then you need some provisions in your agreement to allow for that. Some of us have X number of dollars plus $50 per foot or whatever it is for finding things. Anybody else want to volunteer how much you're charging for maintenance? Bunch of chickens. Nobody? Okay, fair enough. Yeah, thanks, Terry. Yeah, Terry's on right now. Just hang on. Nice. Yeah. Do you have a provision, Terry, where, if things are 8 feet deep, it's extra? Nice. Right. Yeah. Well, I don't have any intent of putting words in your mouth, Terry, but I would suggest that if it's a recurring thing, right? Like if you're going back there year after year, then that can be cheaper, right? I mean, not cheaper than what you're saying. I'm just saying that cuts the cost for you, right? Because you know where everything is, etc. Yeah. Yeah, I forgot to paraphrase again. So for the recording, Terry was talking about, what was it, Terry? 150 to 250 in general, Awesome. Yeah. And then I think they could get the gist of our conversation based on what I was saying. And you brought up another great point, is that if you've got your business built up, like Terry does, Terry's a pretty big player, then you can be efficient because you don't have to go, from Vanderhoof to Terrace in one day, or from Qualicum Beach to Victoria. You can line these things up so that on any given day you're going to places that are close to each other. I remember Reese is online here, I think. Is he? Yeah. Talking to him years ago, he had the same scenario where they had so many service contracts that they could be very efficient in terms of driving around, schedule things accordingly. And then somebody else popped on. Somebody else want to weigh in on this? I cut somebody off because Terry was talking. Feel free to join in. Okay. And then the next point I had up is find all the components. That was always the case, but now the SPM is crystal clear. And just from a standard of due diligence, you can't do maintenance if you don't find things. For example, an old system, you have to find the D-box. You can't maintain the thing without looking in the D-box, and it probably needs some attention. Equalizing flows to each lateral, finding out whether you need flushing and jetting. On that just reminded me, this is about equipment. I was chatting with somebody before we started, like between 6:30 and 7, and we were talking about pumper trucks. You do not need a pumper truck to be a maintenance provider, but if you do, good for you. Then you can send them 2 bills, one for maintenance and one for flushing and jetting, or one for maintenance and one for septic tank pump out. But maintenance providers I don't think, if you have a pumper truck, don't bring it. You can't afford to do several hours of maintenance while your pumper truck is idling at the curb. That thing needs to make money, right? There's no money in trucking. I mean, the only way to make money in trucking is to keep the truck moving with a payload. So those are 2 different things. Maintenance providers determine whether it needs pump out or not. So you can do your maintenance, you can recommend to the owner that, yeah, you need pump out, and then you can go, right? That can be somebody else doing it or your other crew and so on. Use proper reporting terminology. We've been there twice already. That's not to say the system has failed, but to say it's in a performance malfunction condition, etc. Use some kind of a contract to protect yourself. Any questions or thoughts on that? Okay, a few more slides and then we'll get into some content that some of you have already heard. Critical standards are maintenance provider standards. Vertical separation, horizontal separation, daily design flow, maybe also the basics of system selection, whether gravity is allowed and that kind of stuff, because you're making conclusions. So there's no point giving the thumbs up that everything's operating in a normal manner as intended by its design if the thing is 10 feet from a lake, or if the bottom of the trench is underwater during the wet season, or if the thing is overloaded. So those are maintenance provider standards. And then we have these that are clearly maintenance provider standards. 2.3.8, we looked at that the other night. Basically says you have to follow the maintenance plan. Specs and installation standards. So if you're a maintenance provider and you're going to start doing repairs, you need to understand what's involved. And a whole bunch of other things in there, like dealing with carburetors and sewage transfer pumps and alarms and flow monitoring and all that kind of stuff. And then section 2.7 was, I think it was something like 30 pages, maybe a little less, of maintenance, scope of maintenance, the things that we actually have to do. So in 2.7 we have the standards, in 3.7 or 3-7 we have the corresponding guidelines, and those are maintenance provider standards. So again, check webinar number 5 for 2.6 and 3.6, which dealt with, so that's in the specs and installation part, not the maintenance part. Section 6 is specs and installation. And that's where we get flow monitoring, access provisions, effluent filters, all kinds of other things. There's where we get the standards for pump discharge to tanks, for tank installation, for observation ports, new standards for drip systems, siphons, flouts, Alberta at-grades, combined treatment dispersal system, and all those other things are all in 2.6 and 3.6. Then check out webinar number 7 for 2.7 and 3.7, which dealt with those existing systems and system repair in greater detail. We just barely touched on it tonight. That's where it explains what maintenance plans are supposed to include, and as a maintenance provider you need to be able to create a simplified maintenance plan. And it had content about flow monitoring, access provisions, maintenance and monitoring frequency was super important as a maintenance provider, because as we saw the other night in webinar number 7, these are completely different and variable. Right? The SPM gives us new frequency for the initial maintenance, and then we're supposed to know how to stretch that out or how to justify changing the frequency as the system continues in use, in other words, in subsequent years. And then maintenance procedures we talked about. Any questions or thoughts on that? Okay. So frankly, I don't want to lose everybody, but now we are getting into the distinctions between treatment methods, discharge point, point of application, and we're going to talk about vertical separation, horizontal setbacks, and DDF. And a lot of you on tonight have already done that, so feel free to stay or feel free to log out if it's going to be repetitive. I hopefully didn't mislead you that this was going to be entirely new content, so the best I can do is be upfront with you and say that it's even going to use the same examples. We're going to go through some DDF examples that some of you have already done. Okay, so 2.1.2, we want to capture this. Point of application in a traditional system is the D-box or the manifold. Right? So before that is the treatment method. Hopefully we're not going to have any more people calling gravity systems type 1. Type 1 has nothing to do with the method of dispersal. Type 1 is septic tank only, whether it goes to a drip system or a pressure system or a sand mound or a gravity system. Type 2 or 3 have specific parameters defined in the regulation, typically done by treatment plants or combined treatment and dispersal systems. So once again, for a CTDS, the point of application is a defined elevation in the soil, typically underneath a foot of sand that the manufacturers require. Whether it's a foot or 6 inches or none, that's their business, right? It's where they are claiming to meet type 2 or 3, and above that line is their problem. Yeah, I should say that more carefully. At least we're relying on their recommendations for sizing and configuring the portion above that. But below the point of application, it's the authorized person that specifies the system. The size, the configuration, determining whether it has adequate vertical separation, and so on. Everything below that is our problem. So don't believe the salesman. Frankly, we see a lot of CTDS systems that are below water table. I don't necessarily know whether that's the salesman's fault or not, but below that point of application, we have to have adequate vertical separation, and we have to decide whether it's uniform distribution or not, and all the other standards apply, and that's our problem below that point of application. What else do I have here? General standards, emergency measures 2.1.1. What the heck was that again? 2.1.1. So again, this is important for maintenance providers in case they missed it earlier. Emergency measures, once again, it says notify the health authority in writing and keep that proof of due diligence. And then this stuff, under an emergency, you can carry out immediate repairs to eliminate the risk without a filing, and it does not have to comply with the SPM. You can maintain the function of it until permanent repairs or replacements can be carried out under a filing. Next bit I had was new use of existing system. There's frankly quite a bit more about that in the guidelines. Bear with me here. Actually, the next thing I had was all this on repairs. So for all repairs, confirm DDF, assess and document all components, check for drinking water well setbacks. And for repairs, we do not necessarily have to be 30 meters from wells. We have to be the old standard, which I think was 15 meters, right? 50 feet. And all that is laid out in the policy down in there, that document from the Ministry of Health. So maintenance providers need to be familiar with that. If you're replacing the system, it has to be 30 meters from a well, but not necessarily for repair. And we had component repair versus system repair in that table. We've been there a number of times, that table. And there we go, upgrades and new use of an existing system. So, when doing that, it should comply with the standards in this volume. And when assessing, it talks about establishing DDF, vertical separation, and so on. And well, that's probably enough said for now because we dealt with that in previous webinars. Maintenance and monitoring 3.8. There it is again. It says when you're maintaining a system, you have to follow the maintenance plan. According to the maintenance plan and the standards in this manual. What else do we want to touch on? Make sure it's performing properly or as intended, more precisely. Write a brief report to the client. Again, report all maintenance to the owner and report health hazards to the health authority. This one is important. There's a lot of liability there because now it's starting to sound a lot like a performance inspection. And maybe the distinction is a bit subtle because now we're exposed to a lot of liability. If we're confirming the thing is performing properly, then we better be right and we better use the right terminology. Write a brief report. There we go. Standards for selecting a system. Once again, I'm starting to get stretched for time, but I would just encourage you to look at those site capability tables. Table 2.5 talks about whether gravity is allowed or not. 2.6 has key constraints for systems around slope and floodplains and some other stuff. Table 2.7 talks about soil constraints. Hard consistency, for example, is a limiting layer and some other things. So look at all those things on your own time. And now we're getting into the changes to horizontal separation and so on. So this is intended for maintenance providers who maybe missed those earlier webinars. And we want to point out there's a new presentation. There's new tables. And horizontal separation is in 5.4. So there is our new presentation. For one thing, there's no distinctions between different treatment type or dispersal methods. The setbacks used to be different for type 1, 2, and 3 and for gravity versus pressure. Now the setbacks are the same for every system type, whether it's type 1, 2, 3, gravity, drip, sand mounds, etc., with the only exception being lagoons, which have their own table now. Right? So lagoons have their own distinct table. And in a previous webinar, we talked about a lot of changes in here. In other words, a lot of these numbers have changed. There's a 0 meter setback from tanks to perimeter drain and so on. So just to recap from my slide, no distinction for treatment type, dispersal method, new specific numbers, new details for lagoons. Horizontal separation is measured from a performance boundary to the infiltrative surface. Performance boundary is a well, a creek, a breakout point, interceptor drain, and so on. And the infiltrative surface is defined in that section for different system types. Generally, it's the edge of the trench or the bed. All that stuff about minimum basal area of sand mounds, it's still there in terms of designing the thing, but not for measuring horizontal separation. By the way, that's the new term, is horizontal separation, not setbacks. Horizontal separation. Table 219, again, because I'm running out of time, I'm just going to point out that that's the setback table, and it defines water bodies, ditches, drains. It talks about when a ditch is a breakout or not. It talks about where to measure the setback to the ocean and a lake. Ocean mean high tide, lake high water. Purpose of VHS. In this section in the guideline, it basically says that horizontal separation is a safety factor. And it's a safety factor intended mostly if the system starts to fail, because we're supposed to have an adequate treatment in our dispersal system so that within 2 feet of the infiltrative surface it's met recreational water quality standards, not 30 meters. So horizontal separation is a safety, a risk management strategy. It points out in the guidelines that other regs may apply for setbacks, a lot of local setbacks that exceed the setbacks in our SPM. Lake country, other areas around Shuswap, Fort St. George, a bunch of other lakes, and even things that aren't around lakes have covenants in place where you have to have setbacks in excess of the SPM, and we're supposed to check for those. It also talks about what constitutes a breakout risk. Check on that in your own time. Basically, not everything that looks like a breakout risk is. It could be an interceptor drain that's just slightly lower than the infiltrative surface, for example. Some ditches are not a breakout risk. Depends on how much water and how often and some other things. And then the non-critical setbacks are no longer in the critical standards. They're in the guidelines where they probably should have been all along. So 3.5.4 gives us our non-critical setbacks. There, by the way, was definitions of breakout. There it is. That's where we get our horizontal setbacks to property lines and buildings where there's no perimeter drain, utilities, and so on. So that was a change. Hydraulic loading rates, I'm going to skip because I actually want to get through this. If you need to write the exam, you need to understand how to calculate daily design flow, and you need to understand vertical separation. Strictly speaking, the hydraulic and linear loading rates are something that you should know, but maybe don't have to. It's a bit of a gray area because we're now having to make a conclusion about how big the system is and compare it to how big the system should be, which implies that you need to understand hydraulic and linear loading so you can figure out whether the system is big enough. But what? But your other option is just to rely on your good old common sense and experience. You know, if the DDF for the original system was 250 gallons a day, and your system only has 100 feet of trenches in it, it probably doesn't have enough capacity. Or vice versa. You know, if you have a 5-bedroom house and 100 feet of trenches, it probably doesn't meet hydraulic or linear loading. But I'm going to leave it because that's something you can capture by accessing a previous webinar or on your own. So I'm going to skip a whole bunch of stuff. Hydraulic loading rates is a new application It now is a two-pronged approach dealing with soil characteristics and permeability or perk rates. I had some examples. Linear loading, same issue. The short version is put your systems on the contour, not down the slope. And if they are going down the slope, you need to report that as non-compliance. And understand that the system length is the length on the contour, not the sum of trench lengths. So if linear loading says the thing needs to be 100 feet long, that is not 4 25-foot long trenches from an end-feed D box. 4 25-foot trenches is a system length of 25 feet, not 100 feet in terms of system contour length. And there was a bunch of changes. Linear loading is now much more generous for sandy soils, allows much shorter systems, and it's also a two-pronged approach where you select it based on soil characteristics or permeability and perk rate and choose the most conservative of the two. Had some examples I guess we don't have time for, and let's move on to the stuff that you will need to know, particularly if you need to write the exam. Daily design flow has changed a lot. It's much reduced. DDF is much less than it used to be, and DDF is in section 5. So all these numbers for DDF are much lower than they used to be. That's one reason why it's less. For example, for a 2-bedroom it used to be 1136, now it's 1000. For a 4-bedroom it used to be 1700, now it's 1600. Another reason why it's less is we now have a separate category for 1-bedroom residence. That used to be lumped together with the 2-bedroom residence. The third reason why these are less is because the maximum floor area is much greater. So that column is the threshold after which we have to add a DDF allowance for so-called extra living area. And since these numbers are much larger, then DDF becomes smaller for a typical house, I suppose, because under the old DDFs, there were lots of houses where we had to create the extra allowance. Then the fourth reason why DDF is less is that when our area exceeds these numbers in this column, we only have to add 3 liters per meter squared, not 4.5. So for all those reasons, lower DDF. The application is based on number of bedrooms or per capita meaning occupancy, so 2 different tables. So first we base it on bedrooms, has nothing to do with how many fixtures or toilets or anything like that. It is based on the number of bedrooms, and then the two-pronged approach is an occupancy check. So we have to determine it by referencing both of those tables and then choosing the greater of the two. So if we had a 3-bedroom house, the previous table says DDF is 1300 as long as the floor area is less than 280 meters squared, and it probably is because that's a pretty big house. So 1300 is the first answer. Now we check it against occupancy. 3-bedroom house. 3-bedroom house, if it has 4 people, then we have to use this per capita method. Don't be distracted by the fraction. Nobody's suggesting there's 3/4 of a person. It's just that 3.75 times 350 is more or less 1300. So it means 4. So if there's 4 people anticipated in the house or in the house, then the DDF is 4 times 350, which is not 1300. New stuff about garbage grinders and carburetors and grinder pumps and macerators. A little more on that later. The key point is that allowable flow is average flow, and for a maintenance provider to get that wrong is a pretty big screw up because it's called maintenance and monitoring. Right? So monitoring is just as important as the rest of it. Monitoring means flow monitoring, and the allowable flow is not DDF. DDF is double the allowable flow. Average flow, it says in this section, is or should be no more than 50% of the DDF on a 30-day average. So in a few of the days in that 30-day period, it could be DDF, but on average, it needs to be average flow, and the maintenance plan is supposed to tell you what average flow is. So flow monitoring is based on average flow. Cycle count times dose volume should be less than or equal to 1/2 of DDF. DDF, on the other hand, is peak flow. That is what we base the system sizing on. It's what we enter in the filing of sewer system form, but it's not what we compare panel records to, flow monitoring to. Design flow is peak flow, and design flow is 2 times average flow. Any questions or thoughts on that? Okay, let's try a few. And we're going to stick to simple ones. It's the same old gray area. Is maintenance providers are required to make conclusions about the size of the system compared to the use. So we need to understand DDF, but I don't think that means you need to have full planning competencies. You need to get the basics though. And here's a basic question, is what's DDF for 3 bedrooms, 260 square meters? So DDF, what was the question again? 3 bedrooms, there we go. 260 square meters is less than 280. Hopefully you can make metric conversions, by the way. So 260 square meters, 3 bedroom. The answer to that question is 1,300 as long as the occupancy isn't excessive. But for learning value, I just left the occupancy out. That's all the information we have, so the answer is 1,300. Next question is 3-bedroom house with 230 square meters of living area. So 3-bedroom house, 230 is less than 240, but that does not mean that the DDF now becomes 1,000 because it's still a 3-bedroom house. It could have 100 square meters and the DDF is still 1,300. No reductions for less living area. Next, 3-bedroom house, 290 square meters. Pretty simple, really. It may not seem like it, but I hope that it is. We now have the excess living area. Right? It has, the question number 3 says 290 square meters, which is 10 meters more, 10 square meters more than the maximum floor area. So the answer is 1,300 plus an allowance of 3 liters per meter squared that exceeds 280. In other words, 10 times 3 is 30. DDF for that information is 1,330. Next. 3 bedrooms, 5 occupants are anticipated. So all the questions in the real world we would have had to have known what the anticipated or current occupancy is. But here we go. So 3 bedrooms, 1,300, that's the first half of the 2-pronged approach. Occupancy check, next page, next table. 3-bedroom house, minimum number of occupants, 3.75, and the question says 5. So 5 is more than 4, more than 3.75. So the answer now is that we do have to use the per capita. The answer is 5 times 350, which is 1,750, not 1,300. A few more based on occupancy, I guess. DDF, you use it for either bedrooms or household occupancy, and you choose the most conservative of the two, in other words, the bigger DDF. And a few examples. 3 bedrooms, 266 persons. So you're on to me by now. 6 persons is more than 3.75. So the answer is 6 times 350 equals 2,100. Next question. 4 bedrooms, 6 persons. 4 bedrooms. By the way, the living area was okay, right? The living area was 230, which is less than that. And the occupancy is still the same. 4-bedroom house, 6 is more than 4.5, so it's 6 times 350, which is the same as the last question. In other words, once again, 2100. Next one, 5 bedrooms, 6 persons. 5 is more than, was it 5? 6. 6 is more than 5.5, so the answer is 6 times 350, which is still 2100, isn't it? Sure it is. Yeah, they were all 6 persons. So the answer is still 2100. Then the next one, to look at it the opposite way, what if there's not many occupants, 2 bedrooms, 75 square meters, 1 person occupancy? Well, the living area, we can't make deductions based on it being tiny, right? 75 is less than 240, but it says 1 person, not but also 1 person in a 2-bedroom house is less than 3, but we can't then go 1 times 350 and make that DDF. It's the bigger of the two. So the answer for number 4 is 2-bedroom house, 1000. And there's more exercises on the website and the learning resources. Any questions or thoughts on that? A little bit. Suites. I thought I was in good shape tonight in terms of time, but apparently not. So the short answer for suites is you need to add the two together. For a house that has a suite in the basement, for example, if there's 2 bedrooms upstairs and 1 bedroom in the suite, the DDF is not for a 3-bedroom house, it's for a 2-bedroom house plus a 1-bedroom house. I hope everybody gets that. And we'll do a few examples. So here's a 2-bedroom. It's got 200 square meters and a secondary suite that has 1 bedroom and 55 meters squared. Well, let's just stick with that for now as the limited information. The answer is the DDF for a 2-bedroom plus the DDF for a 1-bedroom. So it is 1000 plus 700. The answer is 1700 liters DDF. And now occupancy. If the occupancy was 3 persons in the 2-bedroom, 2 persons in the 1-bedroom, that actually falls within that table. Right? For a 2-bedroom, 3 is okay. For a 1-bedroom, 2 is okay. So the answer is still 1700. No additional DDF required. Next one. We got 4 bedrooms with 500 meters squared, 4 occupants, and a detached rental cabin with full-time occupancy, 2 persons, and so on. So it is the two added together. It's the DDF for the 4-bedroom residence plus the DDF for the cabin that has 1 bedroom. So it's going to be whatever DDF is for the 4-bedroom, plus it's going to be 700 liters for the 1-bedroom. The trouble with this question is we do have an extra living allowance. Occupancy was okay, and area was not, because the 4-bedroom has 500 meters squared, which is more than 330. So we got to get 500 minus 330 times 3 liters per meter squared and add it to that, to 1600, and then add it to that, the 700 for a 1-bedroom, and that math looks like this. Extra living area allowance plus the 1600 for a 4-bedroom, right? Plus the 700 liters for the 1-bedroom. So DDF was 2810. And if you need to write the exam, you need to be able to do that. We have a whole whole nother webinar on that and a bunch of learning resources on the web page. And next point, residential sewage. Maintenance providers need to understand that the tables and so on are for normal residential sewage, not high strength sewage. And we have tables for that in volume 3, that section, and we need to confirm that sewage strength and characteristics meet that. It doesn't necessarily mean that you need to do lab sampling of sewage, but it means that if there's any indication that it might not be ordinary residential sewage, then you do need to do sampling. And you compare it to these parameters. So this is a significant change. An important point is we have these parameters in the SPM, and if our sewage or type 1 effluent doesn't fall within those, then none of the standards apply, right? DDF, hydraulic loading, linear loading, none of that applies because the math that underlies those standards was based on these quantifiable parameters, which is what it says there. Equivalent strength and flow characteristics to that table. Any thoughts or questions on that? Carburetors, I think I can give you the short version, is if garbage grinders or carburetors, you have to increase DDF by a factor of 1.5, which means everything is bigger by 50%, tanks and so on. So if they have a garbage grinder and they put it in after the system was designed and installed, they are probably overloading the system by at least 50%. It becomes a pretty expensive garbage grinder. Grinder pump, similar but different. It's all about increased total suspended solids, right? More mass loading reaching the soil. Grinder pumps don't require an increase to DDF. They require an increase to the septic tank capacity by a factor of 2, double. But DDF still stays the same. So the system sizing of the soil dispersal sizing stays the same. It's just the septic tank. So just the septic tank for grinders, the entire system for what? Carburetors. Okay, grinder pumps. And any questions or thoughts on that? I guess I'll skip this stuff. Distribution and dosing, types of distribution. Hopefully maintenance providers understand that dose to D box is still gravity, and so on. There's a very extensive dosing standards, and now we go to vertical separation. So maintenance providers need to check vertical separation. We saw that at the beginning of tonight's webinar. And we need to be sure we understand what that is. Sadly enough, a lot of people don't. It's the height or the depth of unsaturated soil from the infiltration surface to the limiting layer. Infiltrative surface is typically the bottom of the trench or the bed. It's not the surface grade or the original grade of the site unless the infiltrative surface happens to be on the surface. So typically it's the bottom of a trench, base of a bed, the point of application for a CTDS, not underneath the fabric or the peat or whatever, but rather at the point of application defined by the manufacturer, which is often underneath a foot of sand. For drip systems, it's the actual emitters, since there's no drain rock and so on. So, bear with me, a little more on VS. The glossary says this: it makes a distinction between native VS and as constructed, and so do the standards. In other words, there's two different VS standards we need to meet. One of them is the VS in native soil, and the other is the depth in native soil plus any sand media. So a sand mound, for example. And again, different standards for both of those. We need to understand the distinction. As constructed VS can never be less than native VS. A lot of people are still reporting the depth of the soil on the lot as this, which is not VS unless the system is at grade. And then they report as constructed VS as how much soil is left over after they dig a trench or a bed. And that's wrong. As constructed has to be either the same or more and can never be less. And this to me should be obvious. If the depth is limited, you can raise the infiltrative surface to meet VS. You can put it shallow at the surface or above the surface on a layer of sand media fill, above grade or a raised system. In other words, you can adjust the depth of your trench to meet VS. Your trench could be 4 inches deep and then add cover soil, or it could be at grade or raised. Gravity systems can't really be raised to meet VS, but they can be shallow or at grade with cover soil added. Uniform distribution systems, in other words, pressure or drip, can be used below grade, shallow, at grade, or above grade. So now we can go up on sand media. At-grade beds and Alberta at-grades are specialized forms of at-grade systems, it says, and as I mentioned in previous webinars, that's not the same. An at-grade bed is not the same as a seepage bed placed at an at-grade elevation. A seepage bed that happens to be at grade is a seepage bed. It needs to be level and have consistent spacing between laterals and so on. An at-grade bed is a different thing, capital A at-grade bed, where it's placed on the native interface, on the slope, on the irregular slope, and so on. Moving on, topic is VS. So, yeah, you might be well advised to go back to that vertical separation seminar or webinar if you're going to write the quiz. But here's the short version. If the sand layer is more than 30 centimeters, then it becomes a sand mound and all the standards for a sand mound apply. If it's less than that, then it's not a sand mound. It's just a blinding layer of sand. Limiting conditions. Often people still misunderstand the limiting layer. We're measuring VS from the infiltrative surface to a limiting layer, and the limiting layer is the shallowest of restrictive water table, seasonal high water table, or even extremely permeable material. So gravel, for example, just basically rock, is a limiting condition. Usually the issue is seasonal high water table, which is much higher than restrictive layer. Right? So almost never is a limiting condition the restrictive layer of clay. It's usually something higher because seasonal saturation is higher. And glossary defines restrictive layer, which I think everybody gets, right? It's hard pan or rock, except this part. A restrictive layer includes soils with hard consistency, harder than moderately hard. And again, a bit of a gray area. Maintenance providers don't have to be experts in soil classification, but you should at least get the fundamentals of this, that if it looks like this, that's a limiting condition. I realize it's a picture, you don't have it in your hand, but this head, this block, is fairly hard. You can kind of tell, otherwise it'd be falling apart, right? And it takes quite a bit of pressure to squish that. That means that a trench or a bed would have to be 2 feet or 3 feet or 5 feet, depending on the type of system, above that stuff. Right? That's a limiting condition, even though it has some roots in it. Right? Root growth is an indicator of seasonal saturation and so on, but this is a limiting condition just because it's hard. And it also has some redoxomorphic features. All this stuff is all indicating seasonal high water table. And another picture of the same site. It's hard and it's mottled. All this rust shows that it's a limiting layer based on seasonal saturation. All that stuff, all that rust means that the system will have to be 2 feet, 3 feet, or 5 feet above that. If you didn't have a restrictive layer below that, it's still a limiting layer. Yeah. So, you mean like you dig below it? And then, If it was only 6 or 8 inches thick, good question. Then you can do a sand line trench, right? But not in this picture because of the modeling. You know, but if it was just because it was hard, John, good question, then you could, shall we say, break through it. You know, if there was sand underneath this, for example, which can happen, that's what a sand line trench is for. Yeah, good point. Seasonal high water table is the kicker, and seasonal high water table has a specific definition. It actually has to persist for a while, more than 21 consecutive days in a typical year is the short version. And that's a good thing, because otherwise we would have limiting condition right to surface in most parts of the province, probably all parts of the province. Down here in November, December, and January, there are weeks where it's almost completely saturated right to surface. So good thing we have the definition that says it actually has to last for a while. In the north, you know, you get a rain storm coming in when there's 2 feet of snow on the ground and things start melting. You're going to have seasonal high water table right to surface. So again, it has to persist. Seasonal high water table is the problem. It's the most difficult to determine. It's a very common error. We literally see systems underwater, right, at least the base of the trench. Therefore, it has pretty serious implications. So as a maintenance provider, if you see that in your observation ports, that's a definite breach of a critical standard. You need to reveal that, make recommendations to the owner. I lost my train of thought. Even if you see signs of it, like root growth limits and modeling, you need to deal with it. So most of you have seen this before. The limiting layer is probably there. It's a change in root growth, change in color. All of this modeling down here and the lack of roots all indicates seasonal high water table. There's lots of modeling and not very many roots, and the color is washed out. So that means that for this system, if this is the limiting layer in here, our infiltrative surface has to be 2 feet, 3 feet, or 5 feet above that. Well, not 5 feet in this case, because that's applicable to gravity, and gravity can't be above grade by that much. But this job needs a sand mount, right? Whether it be drip or pressure or CTDS or whatever it is, it needs to be above that, including CTDS, right? So some of those, or maybe all of them, are great systems, but people are putting them too deep. There's nothing magic about them. If you're putting, fabric media or, some of those other things, you need to be 2 feet above this red line with it. Not down here, right? That's where my competitors probably would have thought the limiting condition was, because that's moist clay. And if you have any doubts, here's the same test pit in November. It is chocker block full, but thankfully the limiting condition probably is down there, because this was in a very high rainfall event. It doesn't persist for 3 weeks. At least I hope not. At any rate, it had to be a raised system. So let's look at VS, and then we'll call it a night. There are big changes, new tables. There's huge changes to how to determine VS, and they're linked to the site capability standards. Few key points is that for gravity systems, it's now 150 centimeters of VS, used to be 183. Let's see, let's prove it. VS there, and gravity. So it's 150 centimeters for highly permeable soils, and it used to be 183. There is now greater vertical separation for type 2 than there is for type 1. There's a type 2, it needs 120 centimeters of VS from the bottom of the trench to seasonal high water table, which is more than 90. And there's some reasons for that. I guess I'll get to that in a sec. I don't know how I ran out of time so quickly. And there's now vertical separation for lagoons, and it is 90 centimeters. So for lagoons and evapotranspiration absorption beds, it's 90 centimeters to seasonal high water table, or 90 centimeters to a soil type that's no bloody good for a lagoon, like sand. In other words, now sand becomes a limiting layer, not because it's restrictive, but because it's not suitable for a lagoon. So that means 3 feet below the bottom of the lagoon. So if you're digging your lagoon and it starts water pouring in the bottom of it, that means you don't have any VS. The whole idea is to have some dry clay between the bottom of the lagoon and the groundwater table. And that often people just ignore that or miss that bulletin. Lagoon's supposed to fill up with sewage, not groundwater. Moving on, I guess. The VS, greater VS for type 2, again, because I'm so late, I'm just going to speed read this for you. There's a bunch of explanation in the SPM about why, but the main reason is pathogen levels are nearly as high as type 1. We're not disinfecting until we get to type 3. And the loading rates are higher, so we're saturating things more, which means effluent is going to run through the soil more quickly. And since we've made the system half the size, it means we're going to be adding more pathogens per square meter or square foot. And so for all those reasons, well, and also less biomat, right? A little bit of biomat is a good thing. Lots of treatment slows down infiltration. A bunch of biomat is a bad thing because we have clogging. But with less biomat from type 2 and, you know, the first 2 points, all this stuff, therefore we need greater soil depth to get decent retention time and still get the final polishing of effluent in the soil. Yeah, we already went to VS for gravel. There's a two-pronged approach, and you need to understand how to determine required VS, even if you're a maintenance provider. There's the two-pronged approach means first you have to check the type of dosing, figure out whether it's demand or low frequency demand, or timed or low frequency timed. And table 210, where am I going? Am I in VS? Yeah. So the two-pronged approach means that we have to go back to these tables and decide whether it's in this column or that column, and so on, if you get the gist, based on number of doses per day. Now for now, same thing in timed, because there's a different depth of soil required depending on whether it's normal or low. Let's go and have a look. In the VS tables, except for the gravity one, there's different depths for demand as opposed to low frequency demand. Right? So more soil depth required if we're putting out more doses per day. And we'll do a few examples before we wrap up. And then we have a bunch of tables to determine VS, different table for every type of dosing. So we have one table for gravity, and we have a table for uniform, which is drip or pressure, or maybe even CTDS in some cases, with demand dosing, another one for time dosing, another table for sand mounds, and another table for drip. That's our VS stuff. And then VS is based on soil type or permeability, type of dosing, effluent type for each of those distribution methods. In other words, there's a different table for different dosing types, and a different dispersal system types, and a different row in each table based on whether it's demand or low, normal demand or low frequency demand, and so on. And we get this distinction between native and as constructed, and we have to meet both. So let's have a look. Let's pick a simple one. Uniform distribution demand dosing. We have a depth required in native soil and a total depth. So in this example, we need 85 centimeters. We need to meet both columns. So that means that if we had 85 centimeters of native soil underneath the bottom of the trench, we've met both columns. if all we had was 60 centimeters of native soil, we would have to add 25 centimeters of sand. So you need to meet both columns. As constructed may be a native or native soil plus sand media, yeah. And then for mounds, we have 3 columns. We have to get native soil VS. We have to get the minimum depth of sand, and we have to get the as constructed VS, which is native soil plus sand. And let's have a look at that. So for sand mounds, we have 3 different columns. We have to meet, in this example, the native VS. We have to meet the minimum sand media thickness. And in this case, 60, they add up. 60 plus 25 is 85. But they don't add up throughout all the tables. They're not intended to add up. We're intended to meet all 3 of them. So 45, 55, 65, 70. Well, there's one example, I guess. Is in this time dosing, we need to have 75 as constructed VS. We have to have at least 45 centimeters of sand. But if we only had 25 cents of native soil, then we need 50 centimeters of sand in order to meet 75. So we have to meet all 3 of them. Few examples. We're getting close to the end here, gang. Minimum VS type 1 to coarse sand gravity distribution. So we have to find the right table. It's the table for gravity. Table for gravity there. For type 1 effluent is there or there, and coarse sand is up in here. In other words, it's highly permeable soil. So it's not down here, right? It's not there. It's here because it's coarse sand. So the answer is 150 centimeters. It's a 2-pronged approach in that we also have to check permeability right there. So we also need 150 centimeters if perk rate is between half a minute to 5 minutes per inch. And the next question is that 4 minutes per inch. Answer 150 centimeters. Next one, type 1 to sand or sandy loam. So sandy loam is not one of these. Sandy loam shows up there, and the effluent type was type 1, so the answer is 90 centimeters. Next question. Soil with sandy loam texture, but it's type 2 now. So remember, type 2 is greater VS than type 1. So that question is type 2 sandy loam, 120 centimeters. Everybody happy? And here's one where we actually have to go back and figure. No, we don't. Sorry, we don't. Let's stick with that one. The question is telling us whether it's low frequency demand dosing, or telling us that it is. So we do not have to go back and check the dosing to figure out whether it's normal or not, because the question tells it to us, right? So the question said, where to go? A sandy loam uniform distribution. So we have defined the uniform distribution table. Uniform distribution, conventional pressure typically. Uniform distribution. And the rest of the question says, uniform distribution, demand dosing, low frequency demand dosing, no sand media. So it is less than 30 centimeters of sand. And it's sandy loam, so it doesn't show up there. It's an other soil in that case, and it's low frequency demand, type 1, 2, or 3. The answer then is 70 centimeters. That's how much VS we need. And let's try one more, just to point out that there is a drip table now. So for drip table with 20-minute perk rate, we go to the proper table, just that simple. So drip table, it is a other soil. What else did the question say? And the perk rate is 20 minutes per inch, so it's slower than half an inch. Native soil, and the answer then is 45 centimeters. What's the required native VS for a sand mound? You might remember because we're just there. It is 25 centimeters, right? 10 inches. So minimum native VS for a sand mound is 25 centimeters. What is the minimum VS as constructed VS for type 1 time dosing? So sand mound table and type 1 time dosing, regular. Answer, the question was as constructed, so it is 75 centimeters. And one more on the same topic. How much sand depth do we need? If native soil is 25, it's for the same info as in question 2. So we need to meet all 3 columns. We need to make 75 total as constructed. We need to have at least 45 centimeters of sand depth, but we only have 25 centimeters of native soil VS. So 25 plus 45, 55, 65, 70. So that's not the answer. It is not 45 centimeters. The answer is 50 centimeters because we need to meet all 3. And that was the point of that example, I guess. And this one, in the interest of time, I'm going to cut to the chase. It's basically, the question is how deep can we dig the trench and still meet VS for gravity? It is loamy sand, so the VS we needed is 150 cents to save some time. So I don't have to show you that. So the answer is 180 minus 150. In other words, we can dig a trench 30 centimeters deep. And yeah, there's another example with the same idea, and that's kind of enough. Sand mound question was similar, and there are learning exercises on that learning resources page, which, just in case we have people here who missed the earlier ones, to get to that you can Google ASTTBC, but that's a long convoluted path, or you can Google OWRP, On-Site Wastewater Registration Program. You could also Google SPM Learning Resources and probably get there. But there is our OWRP site. Click on that. 2 sides to it, practitioner, consumer. Go to the practitioner side, that's us. There's a link to SPM Learning Resources top left. And if I click on that, there is the learning exercises I was talking about several times tonight. So certainly if you need to write that exam, you better go there and look at those. And if you want more work on vertical separation, there's one that was designed for planners, but it could be quite helpful to you too. And there's one for maintenance, and it has an answer key. And there's all the recordings for the previous webinars. So that is it, gang. Sorry it went so much over. And you can feel free to log out. But I'll stay on if anybody wants questions or talk about other things. So I'm going to stop the recording and then